A gleaming, futuristic rocket, standing taller than a seven-story building, now sits in the icy expanse of northern Sweden. Its metallic frame, shimmering against the stark white landscape, seems almost otherworldly beneath the Arctic sun. But this is no ordinary launch vehicle. This is Themis, Europe's boldest bid yet to enter the global race for reusable rockets, a race that has already begun to transform the multi-billion-euro space economy and redefine what it means to reach for the stars. For Europe, the stakes could hardly be higher. Themis represents not just a technological experiment, but a test of the continent's ambition, resilience, and ability to shape its own destiny in space. If Themis falters, Europe risks falling even further behind the United States and China, whose advances in reusable launch technology have already redrawn the competitive map. But if Themis succeeds, the ripple effects could unlock a new era of European space exploration, industrial innovation, and strategic independence. The very future of Europe's role in the cosmos may rest on what happens next. To understand how Europe arrived at this pivotal moment, we need to journey back through the continent's long and often tumultuous relationship with the dream of reusable rockets. Europe's fascination with reusability stretches back nearly 50 years. In the heady days of the 1980s, European engineers set their sights on projects like HOTOL, a bold attempt to create a single stage-to-orbit spaceplane that could revolutionize access to space. HOTOL, standing for horizontal takeoff and landing, promised a future where rockets would fly more like airplanes, taking off from runways and returning safely to land. Around the same time, the Hermes spaceplane was conceived as a European answer to the American space shuttle. With its sleek design and ambitious goals, Hermes was meant to showcase Europe's technological prowess and secure a seat at the top table of spacefaring nations. Yet, as is often the case with visionary projects, the reality proved far more challenging than the dream. Both HOTOL and Hermes ran headlong into a wall of technical difficulties and ballooning costs. The engineering hurdles, everything from advanced propulsion systems to thermal protection for re-entry, proved daunting. Political and economic pressures mounted as budgets swelled. By the early 1990s, both projects had been shelved, casualties of their own ambition. Meanwhile, across the Atlantic, NASA's space shuttle continued to fly, capturing the world's imagination and demonstrating the possibility, if not always the practicality, of reusing at least part of a launch vehicle. The United States gained invaluable experience, while Europe, chastened by its earlier setbacks, shifted its focus to more conventional, expendable rockets. This pragmatic pivot led to the rise of the Ariane rocket family. Ariane 4 and then Ariane 5 became the workhorses of European spaceflight, reliable, powerful, and capable of launching satellites, scientific instruments, and even interplanetary probes. Ariane 5, in particular, became a symbol of European engineering excellence, successfully lofting hundreds of payloads into orbit over its decades of service. But there was a catch. These rockets were strictly single-use. Each one, painstakingly built at great expense, was discarded after a single flight, burning up in the atmosphere or crashing into the ocean. While this approach offered reliability, it came at a steep financial and environmental cost. The economics of space launch remained stubbornly expensive, limiting the frequency and ambition of European missions. The winds of change began to blow in the early 21st century. In the United States, entrepreneurial companies like SpaceX and Blue Origin began to challenge the status quo. Elon Musk's SpaceX, in particular, made headlines around the world when it successfully landed a Falcon 9 booster for the first time in the mid-2010s. Suddenly, what had seemed like science fiction, rockets returning to land, ready to fly again, became a tangible reality. SpaceX's relentless drive to refine and reuse its boosters slashed launch costs, increased turnaround speed, and set a new standard for the industry. Meanwhile, China too was investing heavily in reusable launch technology, determined not to be left behind in the next space race. For Europe, the wake-up call was deafening. As SpaceX reused its rockets multiple times, the economic gap between American and European launch offerings widened. The prospect of becoming dependent on foreign launch providers for everything from scientific satellites to military payloads became a real concern for European policymakers. Strategic autonomy, the ability to control not just what Europe sends into orbit, but how it gets there, suddenly took on new urgency. As one European Space Agency, ESA spokesperson put it, Strategic autonomy means controlling not just what we launch, but how we launch it. Without our own reusable launchers, our independence in space is at risk. Thus began a new chapter in Europe's quest for reusability, the birth of Themis. Unlike the ambitious and ultimately doomed projects of decades past, Themis embraces a pragmatic, step-by-step approach. Spearheaded by Ariane Group and supported by the ESA's Future Launchers Preparatory Program, Themis is not about chasing science fiction dreams of single-stage-to-orbit flight. Instead, it focuses on mastering the core technologies that underpin reusability: robust rocket stages, advanced engines, precision landing systems, and rapid refurbishment for repeat flights. Central to Themis is the Prometheus engine, a groundbreaking development in its own right. Powered by liquid methane and liquid oxygen, Prometheus is designed for ease of handling, operational flexibility, and, crucially, in-flight reignition. This means the engine can be shut down and restarted in mid-flight, a key requirement for controlled descent and landing. Prometheus is also engineered to be about 10 times cheaper to build than Europe's previous workhorse, the Vulcan engine, without sacrificing power or reliability. Its construction leverages advanced manufacturing techniques, such as three-dimensional printing, to reduce complexity and cost. In many ways, Prometheus is as much a symbol of Europe's technological renaissance as Themis itself. But building a reusable rocket is not simply a matter of bolting together new engines and landing legs. The challenge is multidimensional, combining aerospace engineering, automation, software, and even logistics. For example, Themis's landing system incorporates grid-fin aerodynamic stabilizers, which allow the rocket to steer itself during descent with remarkable precision. These fins, combined with advanced guidance algorithms and real-time telemetry, enable Themis to aim for a landing site just 20 meters by 20 meters in size, a remarkable feat, given the speeds and forces involved. On the ground, a fleet of helper robots will play a crucial role, disconnecting and reconnecting cables, recovering excess fuel, and ensuring the stage is safe for refurbishment and reuse. This blend of human ingenuity and robotic automation is at the heart of the Themis philosophy. The journey to this point has been anything but simple. In June of 2025, Themis completed an epic 2-week trek from its integration facility in Les Mureaux, France, to the Esrange Space Center in Sweden. The convoy, hauling a rocket nearly 1 meter wider and more than twice as long as a standard road truck, crossed 5 countries and traversed over 2,000 kilometers, navigating highways, ferries, and the unpredictable weather north of the Arctic Circle. The Esrange Space Center, operated by the Swedish Space Corporation, features a newly constructed launch pad, integration building, and mission control center, all purpose-built for the demands of reusable rocket testing. The very infrastructure supporting Themis represents a major investment by Europe in its technological future. Upon arrival, Themis underwent a rigorous series of checks and preparations. First, a fit check ensured that all major components, the engine bay, fuel tanks, avionics, and upper structure, fit together seamlessly and could communicate with each other. Next, the rocket was prepared for its ground test campaign. This began with the installation of its landing legs, which had to be shipped separately due to their size and complexity. Engineers from more than 20 European companies, representing a dozen different countries, worked in concert to integrate systems, test controls, and ready the stage for its biggest trial yet. The first major milestone is the so-called wet dress rehearsal. In this delicate operation, Themis's tanks are filled with cryogenic liquid methane and oxygen, propellants that flow at temperatures below -62 degrees Celsius. Handling these supercooled liquids requires exacting procedures, specialized equipment, and a high degree of teamwork. The goal is to verify that every valve, sensor, and pipe works flawlessly under real-world conditions. Next comes the hot fire test. With Themis clamped securely to the ground, engineers ignite the Prometheus engine, running it through its paces without actual liftoff. This test simulates the stresses of launch, validates the engine's thrust and control systems, and gives teams valuable data on everything from vibration to fuel consumption. But perhaps the most dramatic moment is the upcoming hop test. In this trial, Themis will ignite its engines, lift off to an altitude of just 20 meters, roughly the height of a 6-story building, and attempt a precision landing back on the pad. While this may sound modest compared to orbital launches, it is a crucial step in proving that all the systems, propulsion, guidance, landing, and ground support, work together as intended. The rocket must not only land upright, but do so within a tight margin of error, guided by its grid fins and stabilized by onboard computers. On landing, a team of robots will spring into action, quickly recovering any remaining fuel and preparing the stage for inspection and, eventually, another flight. Why all this meticulous effort? Because reusability is a fundamentally different paradigm from expendable rocketry. As one industry analyst observed, reusability is not just a technical challenge, it's an economic gamble. Building a rocket that can survive the rigors of launch, re-entry, and landing, then fly again with minimal refurbishment, requires designing for durability, reliability, and operational efficiency from the ground up. Every system must be robust enough to withstand repeated stress, yet simple enough to be serviced quickly and cost-effectively. The upfront investment is high, but the potential payoff, a dramatic reduction in launch costs and a leap in flight frequency, is enormous. Themis is not just a technological demonstrator, it is the testbed for a new way of thinking about space access. Its development is supported by the Salto project, a European Union initiative that brings together 25 partners from 12 countries, pooling expertise in fields ranging from vehicle integration to advanced flight control. Notably, companies like Reusable have contributed cutting-edge high-definition cameras and space-grade Ethernet networks, ensuring that every second of every test is captured and analyzed in exquisite detail. The project is also a showcase for European collaboration, demonstrating that, despite linguistic, cultural, and political diversity, the continent can unite to tackle its biggest challenges. Yet the path forward is fraught with uncertainty. Developing reusable rockets is expensive, complex, and risky. Europe's space budgets, while significant, are modest compared to the vast resources available to the United States or China. As the CEO of Arianespace has warned, excessive competition without adequate funding could fragment our efforts. Coordination, rather than duplication, is essential if Europe is to make the most of its talent and resources. Moreover, institutional caution, a legacy of past setbacks, can sometimes slow progress. Experts from organizations like Intereconomics have noted that Europe's approach to reusability remains cautious and incremental, in contrast to the bolder, risk-tolerant strategies seen elsewhere. So, what is at stake if Themis succeeds? The consequences could be transformative. Imagine a Europe where launching a satellite is as routine as booking an airline ticket. Scientific missions, commercial ventures, and even lunar landers could ride to orbit on homegrown reusable vehicles, slashing costs and multiplying opportunities. The cost of sending a single kilogram into orbit, a figure that has long hovered in the tens of thousands of euros, could drop by an order of magnitude, opening the door to new industries, research, and educational programs. European startups, universities, and space agencies could all benefit from a more accessible and dynamic launch ecosystem. Success could also position Europe as a major player in the emerging era of deep space exploration. With reusable rockets as a foundation, the continent could embark on ambitious missions to the Moon, Mars, or even the outer planets, either independently or in collaboration with other space powers. Sharing expertise with NASA, the Chinese National Space Administration, or private sector leaders could accelerate progress and enable joint ventures that push the boundaries of human knowledge. But the risks of failure are equally profound. If Themis falters, if the tests reveal hidden flaws, if budgets are cut, or if competing priorities sap momentum, Europe could fall irrevocably behind. The continent could become a passive customer in the global space market, reliant on others for critical capabilities. Jobs, investment, and influence could drift elsewhere. As the CEO of Rocket Lab has observed, reusable rockets and frequent launches are now the minimum requirements to compete. Anything less, and you're simply out of the game. Yet beyond the headlines and the high-stakes drama, there is a deeper lesson in the story of Themis, one that resonates far beyond the world of rockets and spaceflight. The journey to reusability is a testament to persistence, adaptation, and the power of learning from failure. Decades of setbacks did not extinguish Europe's ambition. Instead, they forged a new, more pragmatic approach. Themis embodies the idea that innovation need not always be about grand leaps. Sometimes, it is the patient integration of new technologies, tested, refined, and proven step by step, that lays the groundwork for revolution. For entrepreneurs, engineers, and dreamers everywhere, Themis offers inspiration and practical wisdom. Focused, incremental progress, grounded in reality but driven by vision, can overcome even the most daunting obstacles. While big dreams capture imaginations, it is often the steady, methodical work behind the scenes that changes the world. And here's a little known detail. At the heart of Themis is a deceptively simple stainless steel tank. Lightweight yet incredibly strong, it draws on lessons from both European and American rocket builders. This quiet innovation, hidden beneath layers of advanced technology, embodies the spirit of the project. Sometimes, the greatest breakthroughs come from reimagining the humble and familiar. Looking ahead, the journey of Themis is just beginning. The tests at Esrange will provide invaluable data that will shape the next generation of European launchers. Already, plans are being discussed for larger, more capable vehicles that could one day compete head-to-head with the likes of SpaceX's Starship or China's Long March rockets. International collaboration remains a strong possibility, with experts suggesting that pooling resources and expertise could accelerate progress and reduce costs. At the same time, Europe's commitment to environmental stewardship may set new standards for sustainable space exploration, balancing ambition with responsibility. For you, the viewer, the story of Themis is more than a tale of rockets and engineering. It is a reminder that progress is possible, even after decades of disappointment. It is proof that with focused effort, collaboration, and a willingness to adapt, even the loftiest goals can be within reach. The next wave of space technology will shape every aspect of our lives, from global communications and navigation to climate science and planetary exploration. As reusable rockets become routine, space will become more accessible not just for governments and corporations, but for students, scientists, and innovators across Europe and beyond. So, will Themis deliver on its promise? The answer is being written right now, one test at a time, on the frozen plains of Sweden. If these trials succeed, Europe will secure its place at the forefront of the new space era, not just as a customer, but as an innovator and leader. The true impact will be measured not only in launches, but in the opportunities, discoveries, and dreams unlocked for generations to come. Thank you for joining us on this journey into the future of space, global economics, and breakthrough technology. If you want to stay up to date with the latest developments and to be part of the conversation shaping our shared destiny beyond Earth, make sure to subscribe and share your thoughts in the comments below. Can Europe catch up in the race for reusable rockets, or is it too late? We want to hear from you. Until next time, keep looking up, stay curious.